4.2, number 44. With what velocity will you hit the water if you step off a 10-meter diving platform? Alright, so we want to know how fast this person is traveling when he or she hits the water. So we need to know that gravity, we're in meters, so gravity is 9.8, so it would be negative. Our acceleration would be negative 9.8. So then our velocity would be negative 9.8 t plus c, antiderivative of acceleration. Our initial value is, we know that when time is 0, our velocity is 0. So we can put 0 in for velocity, 0 in for time, so c is 0. So our velocity equation is negative 9.8 t. Alright, what we know is the time is after we've traveled 10 meters. So if we knew when we hit the water, we could plug that into our velocity equation. But we don't know when we hit the water, so we need to know the position or the height. So I will just call it s. S of t would be the antiderivative of velocity. So negative 4.9 t squared plus c. And our initial value is when time is 0, s is 10. We start 10 meters above sea level. So 10 equals negative 4.9 times 0 squared plus c, so c is 10. C is not always going to be our initial, so don't get in the habit of not solving for C. So go through the process of plugging in time and whatever we have to find C. Okay, so our position is negative 4.9 t squared plus 10. Alright, so now we want to know when is it 10. So we have our position, when is it 0? So our position is 0. And we can solve for t, and that'll tell us when we hit the water. So square root of 10 divided by 4.9 gives me approximately 1.43 seconds, plus or minus, but we're only interested in the positive time. Okay, so we have the time in which it occurs. Now, how fast is it when we hit the water? We need to find v of 1.43. That is negative 9.8 times 1.43. And we get negative 14. So the velocity is negative 14 meters per second. Alright, so that's problem part A. Now same question, but our initial velocity is 2. So this person is going to jump up 2 meters per second. We want to know how fast he or she is traveling when he or she hits the water. So if we think of the velocity of 0 here in the first part of the problem, this is how high he or she is when the velocity is 0. This person's going to jump, so essentially he's going to start somewhere up here at 0, so he or she should be traveling faster than, so B should have a larger answer than A. And luckily I have a lot more room to work on. Alright, so acceleration is the same. Gravity is not changing a whole lot. So V is negative 9.8 t plus c, and we know when time is 0, our velocity is 2. That's given to us. So 2 equals negative 9.8 times 0 plus c, so c equals 2. So our velocity equation is negative 9.8 t plus 2. Now we need to find our position equation. So s of t would be negative 4.9 t squared plus 2t plus c. And when time is 0, s is 10. We start 10 meters up. So 10 equals negative 4.90 squared plus 2 times 0 plus c. So c equals 10. So our position equation is negative 4.9 t squared plus 2t plus 10. Alright. Again, we want to know how fast at impact. So our position is 0, or our height is 0 at that time. Maybe I'll jump up here. Okay, so then 0 equals negative 4.9 t squared plus 2t plus 10. We'll quad that. Negative 4.9, 2, and 10. I'm glad you enjoyed it. So time, negative 1 doesn't make sense, so our time is 1.65 or so. So then we can plug that into our velocity equation. V of 1.65 equals negative 9.8 times 1.65 plus 2. We'll plug it in right here. So negative 9.8 times 1.65 plus 2 equals negative 14.17 meters per second. So just a little bit faster than the first scenario.